Good evening, everyone, and welcome to Alberta Wilderness Association's third talk of 2022. My name is 𝘏𝘪𝘥𝘥𝘦, and I work as a conservation specialist with AWA, and I'll be moderating tonight's talk. A reminder just to please mute your microphones if they aren't already, just to avoid any background noise during the presentation. So everyone is aware we are recording this presentation and it will be posted to YouTube at a later date. If you have any questions, please save them for the end. There will be time at the end of the presentation. Also, if you would like to just, type them into the chat bar at any point during the talk, I can go back and read them off at the end. So before we get started, I'd like to take a moment to acknowledge that I'm speaking to you as a resident of Calgary, Alberta, or 𝘏𝘪𝘥𝘰𝘶 in the language of the Blackfoot people. Calgary is part of Treaty 7 territory, the home of the Blackfoot Confederacy, the 𝘏𝘪𝘥𝘰𝘶𝘳𝘨, 𝘏𝘪𝘏𝑥𝑦 and Siksika Nations, as well as Métis Nation of Alberta, Region 3. As a born and raised Calgarian, I'm responsible to my obligations under Treaty 7, and as a descendant of European settlers, I have the responsibility to atone for the mistakes or intentional harm of our ancestors. Through my work with AWA, I'm provided an opportunity to contribute in a hopefully meaningful way towards reconciliation as we seek to protect Alberta's wilderness for current and future generations. Now I'll introduce our speaker for the evening, Dr. Kevin Timoney. He's an ecologist and author of multiple books on environmental issues, including Hidden Scourge, which he'll be speaking about tonight. The floor is yours, Kevin.
Thanks, Phil. Thank you, everyone, for your interest in this topic. Tonight, I'm going to talk to you about Hidden Scourge, exposing the truth about the fossil fuel industry. I started out looking at spills, but I followed the data and I ended up looking at a much larger topic. So first of all, I'd just like to say, when we are dealing with any information about the hydrocarbon industry, we have to learn to see through the smoke of misinformation and disinformation. And indeed, it's everywhere. You can even find it in CBC News. I read a headline recently that said that there were 121 saltwater leaks from Saskatchewan oil industry over a 19-month period. But what they didn't say in the headline was that that was just the spills for pipeline, didn't include the spills from wells and tanks and other facilities. And so the actual number was essentially twice what they were reporting in CBC News. It was 228 saline spills over only 15 months. So it's very easy to be misled, and you really have to pay attention to whenever someone is giving you statistics. So the presentation is divided into 8 parts. First of all, I'll explain how the parts of the study fit together, some of the important concepts we need to understand, the focus of the study, some of the findings. I'll provide a geographic overview, then talk about the disturbance signature of the industry, the cumulative effects, and then try to explain how this all came about through the process of regulatory capture. So how the parts fit together: the book is Hidden Scourge, and then there are 5 other files that are available from the web links at the bottom of the page. You can also just get them from me by sending a request to my email. So those other files contain all of the detailed spills from 5 different jurisdictions and maps and other things that were far too detailed for the book itself. Some of the important concepts now to cover. Regulatory capture is a state in which the decisions, actions, or resources of a regulator are directed away from the public interest in favor of a private interest through the actions of that interest. And it's a quasi-legal form of corruption. Some other important concepts. Many people seem to think that when something is green or it's vegetated, that it's healthy and there's not a problem, but it's actually quite often the opposite. Native prairies are often a light green or even a tan color, and lawns that are highly toxic are green. So we need to sort of get past that belief that green is healthy. That image on the top of the slide here, I show you a healthy savanna on the left, really high biodiversity, 95% native species on a healthy soil. On the right, it's all green, but it's actually 95% exotics, and it's fecal and nitrogen contaminated soil and water. So get past the idea that green means healthy. Second concept here is domain is the range of natural variability in the biological, physical, and chemical components and processes of an ecosystem. Now, a domain shift occurs when the ecosystem is pushed outside the boundaries of its former domain. Bootstrapping is the capacity of an ecosystem to reconstitute after a perturbation. A disturbance signature is a distinct, persistent change in ecosystem attributes, such as in species composition and chemistry. And a shifted baseline occurs when there is a loss of the reference or natural control conditions. So I'll give you a sort of a model of what a domain looks like. If you think of these, of an old growth white spruce forest, it varies from year to year, but its variation is limited to within a certain boundary. But if you push the system too hard, you can actually push it beyond its threshold or tipping point, and it will enter a new stable domain. It won't go back to a white spruce forest. And we see this all the time from the fossil fuel industry, where they stress ecosystems too hard, and they cannot be restored to their former condition. So you can push a system here from the white spruce system to a smooth brome, Canada thistle, common dandelion, weedy meadow, and there's no going back. So the system has lost its capacity to bootstrap, to reconstitute itself. The shifted baseline, we can think of it with an analogy. If we look up at the night sky, we might look up and say, hey, there's no clouds tonight. It's a very starry sky. Isn't that wonderful? But if we had the actual baseline conditions, what we would be realizing is that we have a lot of light pollution or maybe some particulates in the sky, and the system is changing. So in ecology, what we're always trying to do is have a meaningful comparison of the then and the now. And quite often we've lost the original baseline conditions. So here's an example of defaunation in the Swan River, the loss of both bird species, but also the overall abundance of birds, significant declines over a 30-year period. So this is a significant decline, but it's actually far worse in reality, because the data only begin in 1987, which is a couple of decades after the Swan River area started to be subjected to the fossil fuel development. So again, shifted baselines are a big problem that we need to overcome. The focus of the study was upstream production spills. That's spills that occur during the production of gas or crude oil. So I got data from 5 different regulators and over 103,000 spills. I put together field plot data, so actual field plots in spills and controls in 4 different regions. So essentially about 500 plots at the end of the day. And then I used scientific and gray literature, correspondence and interviews. Investigative journalists helped me, and I also did a FOIP of the Alberta Energy Regulator. And you can see here the Gary Larson cartoon here. The public and the AER are at a marriage counselor, and the public is telling the marriage counselor, listen, I've tried to communicate with him, but he's like a broken record. None of your beeswax, none of your beeswax. And unfortunately, that's the experience of most of us who try to get information out of the AER. So as I said, the focus of this study is upstream production spills post 1974. So from 1975 onward, there are many other kinds of spills that we'll just be touching on, including things like missing spills, 1975 onward, conventional upstream spills prior to 1975, unconventional spills from, for example, bitumen production or fracking, refineries and tank farms, product distribution pipelines, trucks and railway cars, interprovincial pipelines, and of course, end users, the millions of end users who spill hydrocarbon products. So we're focusing on only one of that type of spills of hydrocarbons, I should say. So one of the things I tried to do was to determine how many spills there might be prior to the beginning of record keeping in Alberta. And I came up with a bare estimate of 5,000 missing spills by extrapolating backward to 0 wells. But what I eventually found was that that figure of 5,000 was a gross underestimate for reasons that I will make clear as we go through. One of the problems with trying to put together the earlier record is that there were many practices that resulted in extreme contamination that were never recorded, even thought of as spills. For example, here we see storage of crude oil in unlined pits before they had the pipeline capacity. So all across the oil patch, they would simply dig holes and store the crude oil in them until they could pump them out with vacuum trucks. And then once that pit was done, they would simply fill in the pit and leave the residual contaminants in the ground. Another example of missing spills comes from an eyewitness who wrote to me. He said, "We were regularly dispatched to an oil field centered around Didsbury. Maintenance was chronically underfunded. Even in those days, and oil storage tanks leaked like sieves. We would pull into a site to find the dike surrounding the tanks brimming with oil from leaks. A backhoe would breach the dike, oil would pour out onto the surrounding land, and then we would shovel gravel on top of the spill to disguise it. To my knowledge, these leaks and spills were never reported, and no one in authority ever came to inspect them, and the situation would be repeated." And there's similar experiences all across Canada. All right, some of the findings now from Hell's library, which is what I came to think of as the regulatory data in general. Here's a graph that shows the total number of spills of crude oil and saline water per year in Alberta from 1975 to 2018. Those are the blue dots. You'll see a rising and then a falling number of spills per year, ranging from anywhere from, say, 700 up to 2,500 spills per year. And you see in red the annual production of conventional oil. And you see something very strange going on here, where the number of spills is rising in the initial few decades of the data gathering, while the overall production of oil is falling. And you wouldn't expect that in the real world. The reason for this sort of switch between a negative correlation to a positive correlation in the late 90s is, of course, that there were many, many thousands of spills that were never even recorded. And so if they had been recorded, you would expect the number of spills to be up here and just following this pattern with the overall annual production. So you see something like that and you immediately realize that the data keeping is not up to snuff. Another thing we're dealing with is some of the largest spills are even missing from the data. So the two largest spills in Canadian history are not part of the official record of the Alberta Energy Regulator. That is for crude oil, the Atlantic number 3 crude oil release in 1948 near Devon in Leduc, released almost 250,000 cubic meters of crude oil, and it caused, you see the fire here in the lower left. The fire was visible from Edmonton. And the reporter from CBC who flew over it in a small plane said it reminded him of his covering the bombing of Germany during World War II in terms of the conflagration size. So that single spill, which is not part of the record, released a total crude oil volume that almost equals the entire recorded record for crude oil spills. So that sort of raises a red flag and you ask, wow, well, if that one's missing, what about all the others? So what is the total number of spills and what is the total volume for crude oil spilled. For saline water, the situation is even more shocking. The Peace River Oil's #1 Old Salty release took place over 87 years, and it released a total volume that was more than 110 times the total volume that's recorded in the official data for all saline spills. So again, this is just a means to illustrate, here's the Peace River Oil site dumping into the Peace River, that the record that we have to deal with is only a sort of the tip of the dirty iceberg of the actual situation on the land. As we look at other kinds of problems with the regulatory data, we see that the spill locations that they give us are often wildly inaccurate, such that if you were to try to find a spill on the land and you use the AER coordinates, you would have a lot of difficulty unless you had local knowledge or First Nations people to take you to the site because they know exactly where it is. Another way that I looked at the data was to study the spills on satellite imagery. So this is a spill that I caught just basically by accident on a 2002 low resolution image. And interestingly, again, the AER location for the spill is off by 147 meters, but even more interestingly is the size of the spill footprint I measured. So that's just the sort of the main part of the spill footprint was equal to 1,563 square meters. Yet the AER reported that only 0.6 cubic meters of crude oil was spilled, which is of course a physical impossibility for a spill of that size. So it's clear proof that they underreported the volume spilled. More demonstrably false reporting, you'll often find that the locations for spills as they're reported are off by a great distance. This is a spill in the left here, supposedly took place about 500 meters from our house, when it actually took place about 50 kilometers to the north. So there's lots and lots of errors in the data, even today, after all these years, in which they don't have any real quality control. They're just reported by industry to the AER, and then the AER regurgitates the information to the public. And on the right, you see another erroneous spill, supposedly a spill of oil that took place in Fort Chipewyan in 2016. There was no such spill. It's just bad data from the AER. So you can ask yourself, how can such wildly inaccurate information be produced in the first place, then not be corrected by the regulator, and then to be distributed to the public? And the answer to that question is regulatory capture. And we'll get into that in a little bit later in the talk. Another thing I looked at using forensic techniques is to examine the volume of a spill in relation to what was reported as the area impacted, or the spill footprint. Now, the Alberta data are so bad that they can't be used, but the Saskatchewan data are somewhat better. They're semi-quantitative. And when you graph the area impacted versus the sort of the volume of saline spills in the top here and in crude oil in the bottom, you get what ecologists call dust bunny plots. They look like a dust bunny in a corner. And when you get a pattern like that, it tells you that there's a very low correlation between the two variables. So, for example, for a given spill volume, the footprints ranged over 10,000-fold in area, and likewise for a given spill footprint of given square number of meters, the spill volumes that they were reporting also ranged over 10,000-fold. So from that, you understand, of course, that you can't get such variation in nature. You can't, for example, have a 1 cubic meter spill of crude oil that produces a valid footprint from 1 square meter to 10,000 square meters. So you have to think, okay, well, where is the problem in the data? And the problem comes primarily in the Saskatchewan data that the volumes that they're reporting are not credible. Another thing I looked at to sort of assess the validity of the data was to graph the recovery efficiency for both crude oil spills and for saline spills. And what you're seeing here is a graph of crude oil recovery efficiency in relation to the volume spilled. And when I first produced these graphs, I was gobsmacked because I thought, how can we have such a beautiful symmetrical pattern of data points? Well, it took me literally a couple of months thinking of this and trying to figure it out until I finally realized that it's actually caused by subjective choice of numeric values that are constrained by choosing the preferred fractions of a spill volume. So the most commonly reported recovery volumes were no recovery, 0/1, 25% of spills, 1/1, in other words, perfect recovery and 54% of spills. Then thirdly, they would report 1/2 recovered, 1/3, 1/4, 1/5, etc. on down the line. So in other words, they're not actually making measurements of how much they're spilling and how much they're recovering. They're just coming up with a figure they guess at, say 10 cubic meters, and then they tell, did we get it all? Yeah, I think we got it all. So we're going to report we got 10. Or did we get a half of it? Okay, yeah, maybe we got half of it. So essentially what you find here is strong evidence that neither the reported spill volumes nor the recovery volumes are measured. They're actually subjectively chosen by humans. It's fabricated data, in other words. Another way I looked at that was to use what's called Benford analysis. When you use Benford analysis, you're actually looking at the frequency of significant digits in numbers from the numbers 1 through 9. And it turns out that in data sets, in most data sets where you have randomly assigned values, that is made through actual measurements, they will follow a Benford distribution. And when you guess numbers, when you don't actually measure them, you just make them up out of your head, you'll deviate farther and farther from the Benford distribution. So what I did here for Alberta, North Dakota, Montana, Saskatchewan, U.S. Coast Guard, and other data sets, I compared the numeric values being reported to their deviation from a Benford analysis, and we find that the worst of all, that is the most subjective, most guessed at data, are Alberta crude oil recovery efficiency, that's the symbol S up in the upper right, followed by Alberta saline recovery efficiency, and on down. So the four worst, that is the most subjective of the data sets, are all from Alberta. In the lower left, you see the blue dots are government and academic data sets that deviate very little from a expected Benford distribution. So that's strong evidence where you're comparing actual quantitative data in the lower left here with increasingly guessed at subjective data as reported by industry. So when a company spills something, there's a great pressure to report good news. They don't want to be the bearer of bad news, so they'll quite often underestimate the spill volume, overestimate their recovery success, and minimize or not even report the impacts. Why be the bearer of bad news when no one is checking? A few other data sets I looked at were sensitive areas in Alberta. So relative to the Alberta Environmental Protection data, the AER understates the occurrence of sensitive areas at spills by a factor of about 200 times. So essentially what they're doing is they're grossly understating ecological sensitivity. When I brought this to the attention of the AER, they fixed the problem by making a rule that the only valid answer for sensitive areas was to fill in the field as no. In other words, by edict, they said that sensitive areas no longer exist in Alberta. I looked at spill harm rates in Oklahoma, and compared them to spill harm rates in Alberta. So what I looked at was the same spill, either saline or crude oil, for the same volume, and then what did the industry report in terms of their harm. And what I found was that in Oklahoma, the harm rates were 39 to 40 times higher than are reported in Alberta. So in other words, we're grossly understating the rates of harm. And the reported values from Oklahoma are even industry reported, which are always underestimating the damage in the first place. Finally, I looked at causes of spills in Alberta. And you'd think that something as important as determining the cause of a spill, there'd be some important data, but really what I found was an ad hoc collection of illogical categories without any quality control and essentially random noise. So the main conclusion I reached by studying the causes of spills in Alberta is it's a strong evidence of a dysfunctional regulatory culture. Okay, now for a quick overview of spills and well sites and on-the-ground conditions in several jurisdictions. So here we see on the left-hand side, as of the 10th of April, so a couple of days ago, about 79,000 spills distributed across most of Alberta. On the right-hand side, 25,940 complaints from the public about those energy activities. So this could be from smoke or odors or concerns about damage to the land, that sort of thing. So now we're looking at here some of these 79,000 spills in relation to some protected areas in the province. So in the upper left, we see in that box there, that's the 𝘏𝘪𝘥𝘥𝘦 wildland, spills inside that protected area. Similarly, in the caribou wildland in the upper right, in Jasper National Park along the left-hand side, and in the Castle wildland in the lower left. Now, one thing you may be jumping out of your chair at this point, and I certainly did, was how can there be production spills in Jasper National Park? Well, the answer is that there aren't any production spills in Jasper National Park. This is erroneous data right here. So they got the locations wrong for these spills, and they ended up plotting them in Jasper National Park, and they never corrected the errors. Now jumping over to Saskatchewan, we see the distribution of spills across southern Saskatchewan, and then in somewhat more detail in the southeastern to give you an idea what it's like around the town of Oxbow in southeastern Saskatchewan. In North Dakota, most of the spills are located in the sort of the northwest quadrant of the state, and then we zoom in and look at the pattern of spills along the Missouri River in western North Dakota. Moving over to Montana, you see most of the spills in Montana are along the eastern margin, and then we compare the spill pattern with the southeastern Montana and southwestern North Dakota. Jumping over to interprovincial pipeline spills in the top panel, we see spills reported from the National Energy Board between BC and northwestern Ontario, and in the bottom panel from northwestern Ontario to Nova Scotia. Now jumping over to wells, you can see wells cover a large part of the province, except in the mountains and in Wood Buffalo National Park. Again, looking at some of the protected areas, 𝘏𝘪𝘥𝘥𝘦 in the upper left, the caribou in the upper right, the Chinchago wilderness along the left, and in the Castle wildland in the lower left. So there are wells in many of these so-called protected areas. Looking at the distribution of wells across the province here, so here the distribution of wells in the northern third of Alberta and in the central third of Alberta. I know it's shocking. It's hard to get used to such a dense network, and then fossil fuel industry wells in the southern third of Alberta. Now, a lot of people are concerned about abandoned wells. Abandoned wells it's careful. You'd have to be careful not to be misled by the designation shell game that the regulator uses. So there's a lot of argument as to what are abandoned wells. In AER, In 2016, they said there were 85,164, but at that time, the AER chief scientist, who was subsequently fired, said there were more than 170,000 abandoned wells in the province. The really important thing to realize is that we have in Alberta alone about 490,000 wells, all of which should be reclaimed at some point. And we then have thousands of facilities, hundreds of thousands of kilometers of pipelines and roads, and more than 2 million kilometers of seismic lines. So it's a massive footprint across the province. What do conditions look like on the ground at these wells? So here we have a couple of wells in southeastern Alberta near Dinosaur Provincial Park. You see the X here is locating these wells, and this is what they look like, heavily damaged, a lot of bare soil. This would be contaminated ground, and whatever plants are growing here would be more likely exotics than anything else. Certified reclaimed, you hear a lot about reclamation certified wells and reclamation certified pipelines. It's essentially just a designation that the regulator has used. It's more or less meaningless. If we look at these dots here, these are sites that were certified as reclaimed 21 to 22 years ago in various parts of the province. And you see they bear no resemblance to the surrounding natural or semi-natural landscape. So they have not been restored by any stretch of the imagination to anything approaching the original conditions. Another word to keep in mind is remediation. It's not restoration to natural or healthy conditions. It's simply an attempt to clean up an industrial site that is acceptable to the regulator. So you see here, these two photographs are from an area that was certified as reclaimed, and 5 years after this remediation in northwestern Alberta, the planted white spruce are all dying due to salt contamination in the soil. You can see the salt crust on the soil in the lower right. And this is the sort of thing that is acceptable to the Alberta Energy Regulator. And it's essentially a permanently contaminated site now. Okay, switching gears now to the disturbance signature. And why is that important? Well, the disturbance signature is a means for you and others to identify what has happened on the landscape by field marks. So if you're a bird watcher, you know how to identify yellow warblers or magnolia warblers by their field marks. So what I'm going to try to show you now is that there are field marks, there are characteristics of the fossil fuel industry footprint, so you can, decades after the fact, identify that an area has been changed by the industry. So it provides proof of harm and a warning of danger. In other words, there are contaminants to be suspected at these sites. It also allows you to pinpoint the effects and to provide a sort of a footprint of the effects. And it also dispels misconceptions that the AER protects the environment and that hydrocarbon exploitation is sustainable when it is not. So the disturbance signature is a function of the pre-disturbance conditions, the type of disturbances, the number of disturbances, the intensity of those disturbances, the extent, the physical, geographic extent, and then the time since the disturbance. So when you put all those together, that will shape what the disturbance signature will look like. So they vary from place to place depending on the ecological region and depending on the original soils and what happened at that site. So in the upper left here, you see a salt and oil contaminated site in northwestern Alberta, dominated by foxtail barley and alsike clover. In the lower right, more than 70 years after a crude oil spill in the alpine tundra along the Canal Road, there's a very distinct disturbance signature that's making those sites quite different from the undisturbed alpine tundra. Say 4 more different signatures here, from one in the northwestern Alberta, from multiple saline spills, In the upper right, this is in Dixie Processors site in Texas, where they dumped a tremendous amount of hydrocarbons and other chemicals, chlorobenzene, copper, etc., and eventually had to fence the site off and make it a Superfund site. So you look at that site and you say, oh, that's fairly just harmless grass and whatnot along a little rural stream, but it's actually a heavily contaminated site. Lower right here, this is more than 70 years after the Leduc blowout of the Atlantic number 3 site. We have a water repellent soil and an exotic community that's still persisting today. In the lower left, we have where an oil spill has converted a bog fen into a contaminated wetland of great danger to the wildlife. Several more disturbance signatures. So as you sort of pan around this image here, you'll see one of the common features of these disturbed areas is that you'll find that grasses tend to be one of the dominant life forms, and those grasses are quite often exotics. You'll often find things like exotic restricted weeds like scentless chamomile here. A lot of bare ground is characteristic of saline spills. This is a 41-year-old crude oil spill in Sherwood Park. Very strong disturbance signature still. This is a good saline indicator, salt meadowgrass Puccinellia, indicative of a saline spill. This is a cyanobacteria blue-green algal community in the wake of a crude oil spill. This is a contaminated pond where they dug out the area to try to get rid of the contaminants, and they left behind this pond, which is essentially devoid of life in northwestern Alberta. Here's an aerial view of the Atlantic number 3 blowout. You can see these bare soil patches here of water repellent, still contaminated soil more than 70 years after the spill. And here's a time series in the Canal Road of a crude oil spill 35, 55, and 70 years after disturbance. Still more signatures here. Very characteristic saline spill, a lot of bare ground, and then saline tolerant grasses. This is the water repellent soil. Basically, if you pour water on that, it just beads up. And it basically forms this like desert conditions. This area was at one time a black Chernozem, highly productive prairie, and it's now a contaminated wasteland. Here's a certified reclaimed site covered with introduced species, characteristic of all reclaimed well sites that are even, healthy enough to grow anything. And here is a reclaimed pipeline. Again, it's all exotic vegetation here, and this is certified reclaimed. In other words, it's considered to be healthy. 50-year-old saline spill in North Dakota. These saline spills are particularly persistent, even more so than crude oil spills. Another thing I'd like to point out to you is that salinized landscapes are very different from saline landscapes. So natural saline landscapes, such as in the lower right, can be quite biodiverse and support rare forms of plants and soils and vegetation. And in fact, in this one, there's a population of nesting whooping cranes. So that's a healthy boreal patterned saline wetland, one of the rarest wetlands in all of Canada. In comparison to a salinized landscape here, where the soil is contaminated with salt from a spill, the AER reported that it was perfect spill recovery, but it's the electrical conductivity here is so harsh that nothing can grow other than a few extremely tolerant halophytes. So salinized landscapes versus saline landscapes, they're very different as lightning and lightning bugs, as Mark Twain would say. Now, 5-hour presentation in 5 minutes here. So I said I'm going to talk to you about the disturbance indicators, the disturbance signature. So within the industrial footprint, you'll find very many species that are good indicators of disturbance, primarily things like exotic grass species, and that's in various habitats, various regions. We can go into wetlands. We'll find a slightly different suite of good indicators. In the plains rough fescue, another set of indicators, in alpine tundra, likewise. So again, there's no need to get into the details, just to say that we have identified the good indicators for these disturbances. There's also floristic indicators, such as an increased proportion of pollution tolerant and salt tolerant species. Lichens, for example, are typically absent in any type of spill or heavy disturbance. If they're present, they tend to be squamulose types. You'll often find blue-green algal communities on soil and in water. And then a decreased proportion of native species in number of species, their total cover, and their diversity. And then there's vegetation landscape indicators. Like, for example, in wetlands, you'll typically find an increased proportion of weedy meadows and marshes, and a tremendous decrease in peatlands. In general, woody plants are replaced by non-woody plants. That's one of the strongest signatures of the disturbance. And finally, there are physical indicators. So, for example, increased bare ground, decreased organic matter and plant litter. There may be things like loss of soil structure, increased soil water repellency, increased compaction. The soils become very hard, impervious to roots and air. Then there'll be all sorts of chemicals that are left behind in the soil years to even decades after the spills. And in water, similarly, you'll find a suite of various chemicals in the water, but also in the sediments that are indicative of the spills. Then there are also contraindicators. So by contraindicator, I mean things that when you observe species that you observe in the field, they tell you that there is not a problem here, that it's actually a healthy, undisturbed system. So you'll find things like white spruce, black spruce, Labrador tea, leatherleaf, things like that. In marshes and meadows, you'll find a similar suite of native species that if they are disturbed, they will disappear from the disturbance. And if you go to other areas, fescue grassland, plains rough fescue, prairie crocus, good indicators of non-disturbance. And then a large number of species are indicative of undisturbed areas in alpine tundra in the north. When we look at the species composition and the soil attributes of these spills, but also we compare wells and pipelines with natural control conditions, we get a clear compositional break in the undisturbed communities versus the disturbed communities. So we find this in northwestern Alberta, a good divisional break here, in north central and northeastern Alberta, along the Canal Road, and in the plains rough fescue soil attributes. We could go over these many different ordinations and cluster diagrams, but the bottom line here is that when these areas are disturbed, there's a very strong signal that is evident in not only the things that are growing there, but also in the chemical and physical attributes left behind. Okay, switching now to cumulative effects. They are more complex than we can model. Now, this is just a fairly simplified model of the Peace Athabasca Delta that I did some years ago, and I'm just showing you this to illustrate that even an oversimplified model can become quite complex. Now, when we try to make a model where we are predicting what will happen if we disturb the landscape, that's when the models break down entirely. The ability to predict what's going to happen is quite limited. We can generally determine effects after the fact, but we can't predict them that well. So we've already looked at the fossil fuel distribution of spills and wells. And in Alberta alone, that footprint is over 30,000 kilometers squared and growing. But what about the distribution of facilities and pipelines? So if we look here on the left, as of a few days ago, a plot of 5,479 pipeline installations and over 118,000 related facilities. Now, just for fun, my idea of fun is sometimes different from other people's, but I started to check some of these sites in areas that I know well, because I do a lot of work in this area in northern Alberta, and all 6 of the sites were erroneous. So there is no crude oil single well battery here. There's no compressor station or gas gathering system here. There's no crude oil batteries, and there's no gas test batteries. So these are all erroneous data downloaded 2 days ago. And so you have to ask yourself, how can this happen? Here's the distribution of pipelines in the southern half of Alberta. Quite a network. And if we zoom in a little bit here to look at the distribution of pipelines in the South Saskatchewan River area north of Medicine Hat, it's an extremely dense network. Here you can see the South Saskatchewan River here. Now, if we add on top of the pipeline network the distribution of wells in red and then the facilities in green, you get an idea of the incredibly dense footprint of the industry. Switching now to northern Alberta, the distribution of pipelines across the north, and then a little more detail in the area of the town of Swan Hills. Now, seismic lines are a difficult issue because their cumulative effects are always underestimated. People tend to think that they're only affecting the seismic line itself, but we've now found that species diversity can be affected as much as 10 meters in any to either side of a seismic line. So they have major effects, especially when you realize that there's more than 2 million kilometers of them in Alberta. The other problem with seismic lines is that they're very difficult to capture on satellite imagery. So you see here, this is the actual pattern of seismic lines, high density seismic lines near Chipewyan Lake. And this is what the Alberta Biodiversity Monitoring Institute managed to capture. Unfortunately, these data then become sort of the official data set that industry uses to say this is our effect on the landscape, when in fact it's a gross underestimate. So we sort of swim in a sea of cumulative effects, not only from spills, but from the overall footprint of seismic lines and wells and roads and facilities and pipelines, etc. So around here, you get the idea around Lodgepole that everything is affected, because you have not only the structure of the landscape has been changed, but you then have light pollution and noise pollution and groundwater and soil pollution. So, you can basically say this entire area has been affected by the industry, not just the footprint itself. Similarly, we look in northwestern Alberta here, these massive boreal peatlands have been carved up by dense networks of seismic lines. This pond here is a non-natural pond they dug out when they were trying to remove the contaminants from this area. And so this was billed by the AER as an example of certified reclamation, and a good thing that they said they were creating wildlife habitat. But in reality, what they did was they created a contaminated pond that would lure wildlife into the area. Another look at the cumulative effects footprint in southeastern Alberta here. And just for fun, I started to look at some of these sites, and I found out that a lot of the locations for these facilities and the spills are actually wrong. There's nothing here. So there's wherever you try to use the Alberta Energy Regulator's data, you'll find that the locations are wrong, or sometimes they even will say something is a certain kind of facility when it's not, that it's actually a different kind of facility. So very frustrating. The landscapes that are exploited for hydrocarbons, they go through a series of processes from the initial seismic exploration through the development over many decades. And at the end, we are left with a permanently damaged landscape, not only in Alberta, but across the oil patch. And then when we add things like, agriculture, where we've lost the native Peace River prairie here to agriculture, and to, in this area, large scale draining of boreal peatlands and loss of carbon to the atmosphere. It's a perfect storm of effects. And now in recent years, we've added fracking. So these red dots here show you areas across Alberta and part of BC where they are disposing of toxic wastewater in injection wells after fracking. Now, as I said, you can look all over and see the same sort of pattern. So just a quick pan around this slide here in the upper left, over 80 years after a saline spill in 𝘏𝘪𝘥𝘥𝘦𝘯 Lake, Oklahoma, there's a very strong disturbance signature. Top middle is a Superfund site near Liberty, Texas, where they were dumping waste oil in unlined pits, similar to what we did in earlier years in Alberta. Now, the soil and the groundwater became highly contaminated with PAHs, benzene, styrene, and lead. And then they subsequently made housing subdivisions in the area. And the residents then learned of the contamination. They sued. They all had to move away. And then the cleanup has been ongoing and still is ongoing as far as I know. In the upper right here, and again, what I want to show you here is this looks like a perfectly healthy rural landscape, when in reality, it's a highly toxic and dangerous landscape. Going over to Utah, we see a crude oil spill here, and all they're simply doing is using a vacuum truck to suck out what they can. This is a recent saline spill near the Englishman River from Husky Energy. And you can see here a very sharp division between the living and the dying and the dead vegetation as a result of the saline water. And then in the lower right here, a recent Husky Energy crude oil spill into the Saskatchewan River near Maidstone. So it's not just in Alberta, it's everywhere that the hydrocarbons are being produced. Okay, so these rather large and intimidating tables here we won't get into, but just to say that in the book there's a significant discussion of the scientific literature and the effects at various levels, from the ecosystem level to other kinds of levels that summarize the effects of fossil fuel production across the world. So including things like the increasing concentration of greenhouse gases, of course. That's probably the one that most of us are most concerned about. But we also have increased wildfires as a result of the development of hydrocarbons, salinization, on and on. So again, it's all been fairly well documented in the scientific literature. There's also effects at the population and the community level, declines in fisheries, defaunation across the landscape, increased predation along linear disturbances, decreased native biodiversity, and then the social and political effects that lots of us don't think about, but they are very important. We have areas where we have impoverished areas of production and then politically powerful areas of consumption. So we have, in the rural areas, we have the haves and the have-nots, the winners and the losers. The people who are most strongly affected are actually getting the least benefit from the development. We also have loss of traditional use and treaty rights. And then, more sort of general impacts to all of us in society, the privatization of profits while we, the public, bear the increasing financial liability, and of course regulatory capture, and then the meta-organization of the fossil fuel industry is undermining trust in government and causing the erosion of our democratic institutions. Okay, so some take-home messages here. By volume, saline spills are actually more harmful than crude oil spills. In Alberta, saline spill volume is about 3.4 times more than the total crude oil volume. So overall, in Alberta, and this is true elsewhere also, saline spills have far more effect on the landscape and more persistent effect than do crude oil spills. If you look at the gradient of increasing damage intensity as a result of the exploitation, from the least to the greatest, we go from seismic lines to airstrips, spills, pipelines, roads, well sites, batteries and other facilities, and finally to processing plants. The disturbance signature is detectable at all fossil fuel industry sites. In Alberta, the cleanup liability is now more than $260 billion. So from this, you can understand that reclamation is not going to happen for most of the footprint. We have more than 30,000 kilometers in Alberta of what I would argue is permanent ecological damage, and I think that will be the most lasting legacy of the use of hydrocarbons. Okay, now switching to the beast in the room, which is human-caused wildfires. We know a lot about wildfires and increasing in many parts of the world as a result of climate change, but we don't often talk about human-caused wildfires. Well, in Alberta, it's the worst in Canada in terms of the proportion of the area burned by humans. 62% of the Alberta wildfires were caused by humans in 2021, and these fires are extremely costly. So the 2016 Fort McMurray fire cost $9.9 billion in damage and untold hardship. And in the Richardson River fire of 2011, the government would not release the figures to me, although I asked them politely for a long time. So we don't know the total cost of that, but it was in the billions. And yet, in both of these cases where the fires were clearly started by humans, by the industry, no prosecutions were ever made. And I have to ask myself why that would be. Would that have been a political decision that would have exposed that the industry is costing the public billions of dollars? And would the insurance companies have sued the responsible parties? Now, a lot of us have been following the situation, the terrible situation of the fires down in California, but look at the difference in its magnitude. So the red areas are the loss of forests over a 21-year period, 2000 to 2020, inclusive. And we see here that it's an order of magnitude greater than it is in California. So much of the world, in boreal regions in particular, is on fire, and yet we're dithering and we continue to do so little to alleviate the stress that we're putting our planet under. Okay, now one final quick section here. What caused all this? Well, it's regulatory capture by the meta-organization. So first of all, what's a meta-organization? It's a group of organizations whose goal is to protect power, privilege, and profit. The fossil fuel meta-organization has at its core three groups: the producers, so the thousands of companies that are producing the hydrocarbons, the regulators that they work with, and then the production partners, the drilling companies, etc. They're exchanging money and information behind an information firewall. They're surrounded by a large number of support groups in this network, which includes legitimators and think tanks and promoters, quizzling politicians in governments, enablers such as lobby groups, industry organizations, in educational institutions, in industry-sponsored monitoring. And then finally, the most important aspect here is the bottom. The banks, the asset managers, and the insurance companies provide the foundation for the network. Now, if we looked a little bit more closely here and put some names to this organization, so we see things like Canadian Energy Centre, the War Room of Mr. Kenny, Canadian Association of Petroleum Producers, and I put the name on some companies here and some think tanks and promoters and political parties. and various monitoring groups. I'm just trying to put some names here to this sort of faceless organization that is lying within all aspects of our society. Their tendrils are everywhere, and they're working around the clock to undermine climate action so that they can continue to control governments and regulators and maintain their political power and their profits. One of the things they do very effectively is distort information. So this is typically what will happen in an organization, is that information will be gathered at the lowest levels, and as it passes up through the organizational chain, unfavorable information is filtered out, it's rejected, or it's spun to be somewhat more favorable, until at the very top, the executives are only exposed to the most favorable view of their activity. So they don't have a clear understanding of reality. Similarly, the whistleblowers within the organization are not promoted, they're hampered, they're removed as troublemakers, and those people are the most important people in the organization to correct the mistakes. So what we get is things like Chernobyl, Space Shuttle Challenger, and the Alberta Energy Regulator, and then the undermining of our democratic institutions. The control by the meta-organization is undermining our global society's capacity to respond to the existential threats that we're facing worldwide. We need to undergo a successful energy transition, or we risk collapse. The World Economic Forum, in their recent January 2022 report, and this is the world's best economists, came out with their top 5 concerns over the next 10 years, and they are listing from the 1st to the 5th: climate action failure, extreme weather, biodiversity loss, social cohesion erosion, and we've seen a lot of that recently, and finally, livelihood crises. So I followed a long trail of breadcrumbs when I started over 6 years ago. And I started basically with the observation that perfect spill recovery data were too good to be true. And that led me on a really quite a long chain of inductive logic that led me to the very end of my realization that it was regulatory capture that was driving all of the damage to not only our landscape, but also to our democratic institutions and our ability to respond to the threats that we face as democracies. Okay, ending here with some acknowledgements. I'd just like to acknowledge the generosity of the Gavia Group, Laura Jackson and Patrick Lamb, Bob Cameron, Cecile Fausack and Bruce Jackson, Evelyn and Harvey Scott, the Keepers of the Water, and the Federation for the Humanities and Social Sciences of Canada. And I'll leave this slide up and so you can read the other people who contributed to the study. Thank you. Any questions I can entertain?
Yeah, thanks for that, Kevin. Yeah, if there are any questions, please feel free to enter them in the chat. I don't know if we have the mute function disabled for guests, but yeah, if you'd like to put them in the chat, I can read them out. Oh, you're getting some digital claps there, Kevin.
Sorry?
Just yeah, there were some digital claps, some of those emoji claps coming in.
Oh, okay. All right, so Phil, if you can read them to me, then I won't have to deal with reading at the same time.
For sure. There's a comment here. It's a bit of a long comment. I don't know if there's a question there, but it's related to cleanups. But we'll go here from Cliff. Have any lawsuits been successful on spills that you know of?
Not to my knowledge, and the problem is that where would you file the lawsuit? The Alberta Energy Regulator is the legal entity that you'd have to appeal to, and they really don't have a great record for any sort of action to clean up spills. So to my knowledge, no.
All right, thank you for that. Another one here, regulatory capture. Are there any solutions to it? It's a big problem, not only for the petroleum industry.
Yeah, the social scientists and policy experts have studied this quite a lot, and I get into it in the book. So you have to sort of fight it on multiple fronts. You can't just simply replace people within various regulators, because it's a systemic problem. So you need to actually, for regulators, they actually have to be within government rather than standing alone outside of government, so that they have far more accountability to the public. We also need to have energy regulators that are independent of the industry rather than basically funded by the industry, and they become an arm of the industry themselves. We need to have sort of a political change, in the sense that because the industry now funds so many political parties, the system becomes corrupted right from the get-go. Another thing we need is to have public funding of universities and research, rather than what's happened in the last 20 years. The fossil fuel industry has taken over funding of most university research, and that has led to sort of a shift in the focus of researchers to look at problems that are of interest to the industry rather than to society. And it also makes most scientists pretty reluctant to come up with findings that are not what the funders want to hear. So we need to have independent funding for scientists, for sure.
All right, next question here is there any way to get the footprint back? Does bioremediation help? I'm assuming that's referring to just reclaiming the footprint of development.
Well, it depends on how severely disturbed the area is. So seismic lines are probably the least heavily damaged, and even those we found some great difficulty in trying to get them to come back to natural conditions. So yeah, there is some means to make them less damaged, but I don't know of any truly successful restoration of these areas once they've been heavily damaged.
Another question here. How do we get the book, Kevin?
Oh, okay. The book is available on Amazon. It's pretty easy. You just order it from Amazon, or you can order it from McGill Queen's University Press. And then as far as all of the other, or from a bookstore, and all of the other materials, you can just send me an email or go to those other sites in the beginning of this slideshow, and I can send you all the other documents for free. That's
amazing. Thanks for that, Kevin. This is a bit of a broad question here, but maybe you'll have a suggestion. What would you recommend as a starting point to start changing things for the better in relation to these spills?
In relation to spills, well, the best thing you can do for spills is to prevent them so they don't happen in the first place. But the problem is that spills, the fossil fuel industry is dealing with liquids, and liquids by their very nature spill. So as long as we're exploiting hydrocarbons, there are going to be spills. We can decrease the number of spills by better management, but the only way we can stop spills entirely is to stop using fossil fuels.
All right. On similar topic here, thank you for an excellent and shocking presentation. Do you know if the responsibility for reclamation of abandoned wells is held federally or provincially? It is
provincially, unfortunately. Yeah. Yeah, so that's a very bad thing because the provincial record on reclamation and remediation is very poor.
Here's another one that actually, this is probably a good follow-up, is carbon capture going to add to the scourge?
Carbon capture will definitely add to the scourge. It is a scam of great proportions. The only thing that's going to happen with carbon capture is that some companies are going to get very rich. And there have been various good studies done by scientists where they look at the overall life cycle effect of the best carbon capture, and they find that it's only capturing probably about 10% of the carbon that it's being emitted. So it's really just one of these. It sounds good on the surface, but it's not going to work. When you put carbon dioxide in the ground, it will leak. It will get back out, and there are no scientifically credible studies that are encouraging about carbon capture.
Yeah, I know. Specifically related to the Shell Quest carbon capture facility here in Alberta, that there was a recent article that came out saying, I think it had emitted 50% more than it had captured over the time it had been operating. So yeah,
it's amazing. Once you start to actually dig into the science, all of the claims that you read in the newspaper fall apart.
Are you familiar with any NGOs that focus on toxics? There used to be a toxics watch. Does Pembina Institute deal with this issue? Are you aware of anywhere that does?
Not anymore. I mean, Toxics Watch is a good organization, but they generally are not dealing with these issues. They're more dealing with things having to do with the consumer products and things like that. But no, there's no really effective organizations that I know of that is working on spills in particular.
We'll do a couple more here before we wrap up. Here's one saying, are you saying that many of these environmental remediation certificates that are issued are of questionable value or integrity, I guess?
Most definitely, yeah. Unequivocally.
And from what I can see, most of what you are showing is surface level contamination. Do you have any data about contaminated groundwater in the province?
Yeah, and there's some of that in the book. The groundwater situation is another issue entirely. And there's not enough research that's going on right now. So I did manage to find some pretty good evidence where well servicing, for example, was leading to contaminants of, for example, phthalates that they use when they're servicing wells, and those phthalates were getting into the surface waters of lakes, several kilometers distant from where they were being used. So it's probably a much bigger problem than we realize because there's very, very little research on groundwater contamination. It's exceedingly expensive to study, and the only people who have that sort of money are the companies that are causing the problem. So unless we have funding in the public interest, that's not going to be studied.
Right. All right, maybe we'll finish off with this one here, or maybe we'll probably have time for two more. Could forest fires play a role in restoring contaminated areas?
That's a good question. I would say not, because they're not going to remove the contaminants that are in the soil, and they're not going to improve the heavily compacted soil, for example, or to remove the salts from the soil. Another thing that forest fires do that is an important ecological effect is, depending on where they are, they will quite often lead to a pulse of mercury. The mercury is held in the soil and in the organic matter, and when the areas burn, quite often there's a 1 or 2 year pulse of mercury into the water supply in areas of big forest fires, and that causes really large problems for the lake ecosystem. So yeah, forest fires are probably not going to be that helpful.
Right. And we'll finish with this one. Would you be able to suggest 1 or 2 targets for activism to stop new fossil fuel infrastructure?
You know, I think perhaps the most suitable thing you can do is to work actively for the transition to solar and wind. You know, so that's, you can put it towards a positive, something that you can do that causes a shift in the economy away from the demand for fossil fuel. So once the solar and wind and other economies become more powerful and more available worldwide, then the power of the organization, for the fossil fuel organization, will wane, and the demand for their products will also wane. So I would say work towards the green transition is perhaps the best thing we can all do.
Great. I think we'll end it there. So on behalf of AWA, thank you, Kevin, for the talk. That was great, informative. I was able to see this now for the second time, and I find I'm learning stuff every time I see it. Those maps are quite daunting, seeing the extent of the infrastructure and spills across the landscape. But yeah, thank you again, and also thank you to everyone who registered and attended tonight. We had a great turnout.
Thank you, Phil, and thank you for everyone who came to the talk. And send me an email by all means if you have any questions or follow-up comments. There's lorex.ted@gmail.com.
Great. All right, everybody have a good night. Thank you so much.
Thank you. Bye-bye.